Establishing tool radius compensation. When milling the contour of a part, the cutting edge of the milling cutter must be tangent to the contour of the part. This causes the tool center path or the tool path to not coincide with the part contour. During programming, the original part contour must be offset by a radius value. Each feature's coordinate dimensions need to be recalculated to obtain the correct values, which can be especially challenging for complex part contours. Additionally, if the tool wears out, or if rough and finish machining or tool changes are required for the same contour, the tool center path must be recalculated, and the program must be modified, which is very tedious. To solve this problem, the tool radius compensation function is used. The tool radius compensation function allows the CNC system to generate the tool center path in real time based on part contour programmed and the preset offset parameters. With this function, the machining program can be written according to the actual part contour. But the tool radius compensation command must be invoked in the program. The tool radius compensation commands are G41 XYD, G42 XYD, G40 XY. G40 cancels tool radius compensation, G41 applies left compensation, and G42 applies right compensation. The G41 left compensation command is viewed along the tool feed direction, with the tool on the left side of the workpiece contour, while G42 right compensation placed the tool on the right side of the workpiece contour. After establishing tool compensation correctly, the machining program can be written according to the drawing dimensions without manually adding the tool radius value to the basic dimensions. By adjusting the tool radius compensation value, the dimensional accuracy of the part can be ensured, and machining allowance can be removed. As shown in two program segments without tool compensation, the coordinate values corresponding to each basic dimension would need manual adjustment to include the tool radius, significantly increasing the calculation workload. The conditions for establishing radius compensation can be summarized as follows. G41 or G42 must be specified. There must be arc movement within the compensation plane. A compensation number must be specified, but it cannot be D00. The compensation plane G17, G18, or G19 must be specified. G00 or G01 mode must be active, and the movement distance to establish compensation must be greater than the tool radius compensation value. Let's watch a demonstration video comparing machining with and without radius compensation to observe the differences. So, when should G41 and G42 be used? With the spindle rotating clockwise fixed direction, G41 is used for clamp milling and G42 for conventional milling. Clamp milling is often used on CNC milling machines to extend tool life and improve machining accuracy. There are a few important points to consider. When using compensation commands, tool radius compensation can only be established and cancelled in G00 or G01 mode. To ensure the safety of the tool and workpiece during compensation establishment and cancellation, G01 mode is usually used. To ensure machining quality and avoid tool interference, a straight line is generally added between the tool start point and the actual entry point to establish compensation. The movement distance of the compensation segment should be longer than the tool radius value used. Tool radius compensation should ideally be established and cancelled on the same side as the compensation direction. This concludes the content of this lesson.